Okay, so I went ahead and copied over the equations that we ended our last video with over here, just so that they would be handy for me to look at. Oops, I have to change back. We are just continuing this very long example. The problems in this section are very long, I know it. So we want to find out all our coefficients. And so we're going to need to be able to define y equals c0 times x to the 0 plus c1 times x to the 1, so on and so forth. So we always start from c sub 0. But we don't have any information about c0, so we go ahead and say, okay, I guess that's what c0 is. And then we move up to c1, but again, we don't have any information. And those two are unknown constants. We had a second order equation, so it's okay that we have two of them. But after this point, we should be able to solve for each thing that we find. So now we're at c sub 2. And I have this equation right here that tells me what c sub 2 is. It's just going to be minus n times n plus 1 over 2 times c sub 0. And then c sub 3, I'll be able to get from this equation right here. So we're going to have minus n plus 2 times n minus 1 over 6 times c sub 1. And then from here, we're going to be working with our generic c sub k. Oops, I cut off that equation actually. There, good enough. So for any value k, c sub k plus 2 is minus that stuff. And so the next thing we want is to find c sub 4. If we're going to use this equation, c sub 4 is going to happen when we take 2 plus 2 gives us 4. So we're just going to be plugging in k equals 2 to that equation right there. So that's going to give us minus n plus 2 plus 1 is going to give us 3. So n plus 3 times n minus k is 2 over k plus 2. So 2 plus 2 is 4 times k plus 1. So 2 plus 1 is 3. And notice I'm not multiplying these things together to give me like 12. I told you the first time we learned series that causes problems. So just leave it the way it is right now. You can hopefully see from doing lots of these problems that this is going to turn into a factorial type term on the bottom for us. And that's going to be times c sub k, so that's c sub 2 right here. Okay, so let's go ahead and move up to c sub 5. If I'm looking for 5 right here, that means I'm going to want to have 3 plus 2 gives me 5. So I'm looking at k equals 3. Or you can imagine you're just going from the first one was kind of hard to figure out, but now you just add 1 to every number. So we're going to have minus n plus 3 plus 1 is going to give us n plus 4. N minus 3. So these numbers just got bigger is what's happening. And then on the bottom, we're going to have 3 plus 2 is 5 times 4. Again, just going up from 4 times 3. And then the c sub k we look at is c sub 3. And then we have to also remember that c sub 2 and c sub 3 we have equations for. So we can go ahead and plug them in. So our negatives are going to cancel out on both these terms. And we're going to be left with n plus 3 times n minus 2 times n plus 1 times n over 4 times 3 times 2, all times c sub 0, when we just plug in that c sub 2. And then when we plug in this c sub 3, we're going to get the negatives cancel out again. We'll have n plus 4 times n minus 3 times n plus 2 times n minus 1 all over 6 times 5 times 4. Oh, you know what? I'll do it in the order it came. 5 times 4 times 6, all times c sub 1. And I'm going to delete these equations because now I feel like we know the pattern we're going to follow. And I need extra room to rearrange these. Oh, okay, there we go. I just want to put my everything in descending order. That's going to be easier for me to spot a pattern when it shows up. So it's going to give me n plus 3 times n plus 1 times n minus 2. Let's see what that does for us. And then let's see, 4 times 3 times 2 is fine the way it is, all times C0. And then this one, I'll take my n plus 4, my n plus 2, my n minus 3, and my n minus 1. I'm also going to switch this to being 6 times 5 times 4. C1. Some of those orderings might not be good, but we'll see what happens. All right, so now we're going to move up to C sub 6. That's going to use our formula when k equals 4, but you could also just think about going up in numbers. We're going to have n plus 5 times n minus 4 over 6 times 5, all times C sub 4. And since we know what C sub 4 is, we can go ahead and plug that in right now. We're going to have minus n plus 5 times n plus 3 times n plus 1 times n minus 2 times n minus 4 divided by 6 times 5 times 4 times 3 times 2, all times C sub 0. And as I did that one, I rearranged it in that descending order, the same way I did in that second step right there. So hopefully you can see that all those terms came from the two objects I was looking at. And let's just do maybe one more to make sure that we can really see this pattern. So C sub 7 would be when k equals 5. But I'm just going to follow this pattern. That gives us an n plus 6 and an n minus 5. We've just been going up numbers over 7 times 6. And that's going to give me, let's see, a C sub 5 right there. So I go back to my C sub 5 and I start to plug stuff in. I'm going to have a negative sign, n plus 6 times n plus 4 times n plus 2 times n minus, n minus 1, n minus 3, and then n minus 5. These ones actually I just would have wanted to do in the other order. I wasn't thinking about negative numbers right. That's my bad. But it's okay. I'll just fix it right now. Oh, no. All right, there we go. And then down here, let's see, we're going to have 7 times 6. And see, now that double 6 is going to give me trouble. So I'm just going to go ahead and write 7 times 6 times 5 times 4. I'll put like my C1 over 6 right there. No big deal. That's just one extra 6 I have. It doesn't fit into this quote factorial looking thing. So now, hopefully the pattern is kind of clear. We're going to have a like n factorial on the bottom, and we're always going to have these collections of odd numbers for even constants in the positives, and then even numbers in the negatives for those even constants. But then for odd constants, we'll start with combinations of even and then go down to negatives that use odd numbers. Again, having that factorial on the bottom. Oh, and you know what? Here, we can say 6 is actually just 3 times 2. There we go. So 6 times 5 times 4 is the same as 5 times 4 times 3 times 2. So there we go. That gives us our full factorial that we want to see. Great. I wonder if when I did that problem, I accidentally simplified something I shouldn't have. Yep, see, look. There was that 3 times 2 originally that I turned into a 6. I was like, oh, I think I'm doing myself a favor, but I got to this point and there was that random 6 hanging around that didn't fit into my pattern. It was lucky that I spotted it came from a 3 times 2, but if I hadn't, it just would have thrown my whole formula off. Okay, so sorry. what we're going to have is a solution that looks like y equals c0 plus c1x plus c2x squared, so on and so forth. But that should be able to be written as c0 times some solution y1 plus c1 times some solution y2. So let's go ahead and try to write that out. Let's say y should be equal to c0 times some stuff plus c1 times some stuff. And let's see what that stuff is. So for c0, it's going to be itself. And then our first c0 term comes from right here, c sub 2. So it's going to be, oops, it's okay, I'll just have the negative sign right there, plus negative n times n plus 1 over 2. And then that would have an x squared attached to it. Then we'll have plus, we go down to our c sub 4 term is where our next c0 comes in. That's going to give us our, let's do n plus 3 times n plus 1 times n times n minus 2 over 4 factorial. And then that's an x to the 4th type term. And then the next one will be minus, and that's going to give us our n plus 5, n plus 3, down through n minus 4 over 6 factorial times x to the 6th, so on and so forth. And then C1 is going to give us, the first term is C1 times x. Then we check our C3. I did this again. Let's just do our minuses. Minus our n plus 2 times n plus 1 over 3 factorial times a C3, so x cubed term, plus n plus 4 times n plus 2 times n minus 1 times n minus 3 over 5 factorial. This would be a 5th order term. Minus, we start at n plus 6, go down to n minus 5 over 7 factorial, x to the 7. Okay, and I know we've gone real over at this point. We'll talk about the solution in the next video because it's where we get all of our important polynomials from. So go ahead and pause here, take a break, and then come back to talk through what we just found.